All right, so we'll start off this week by looking at equations. And this time they're going to have variables on both sides. So an example, something, we're not going to do this one yet, but there's an example. You've got y's on the left and you've got y's on the right. When you have variables on both sides, what ends up happening is now there's different ways to solve the problem. Some people may decide to move everything to one side. Some people may decide to put everything on the other side. Up until now, we haven't really had to worry about that choice. So that's one thing we're going to have to look at in this section. Okay, so this part, you guys, you don't have to write this down. Okay, I'll let you know when you need to write it. But I'm just explaining what we've done up until now. So all the equations we've solved only had the variable on one side. All right, let's just go over the steps again. Might give you a hint of one of the letters in the steps, but can somebody remind me, what's the word that I use to remember the steps when you're solving an equation? Remember, what's that word? It has 3 letters in it. So it's not PEMDAS. PEMDAS is when you do arithmetic. This is when you solve equations. How about Joe? Do you remember?
Sam.
Yeah, Sam. Very good. So, Sam, what's the S stand for in Sam? Yep. Simplify. So, under simplify, there's 2 things we need to do. Now, there's no spot on the guided notes to write this, because everybody that got guided notes on Thursday last week, they already wrote this down. But if you're new, you may want to write down probably in example 1 off to the side. You'd have some room. Even if you were here and you want to write it again, just to remind yourself, you could, but you already have it on your guided notes from Thursday. Okay, simplify. What's 2 things that we do under simplify? What's the first one? Remember, how about Dorian? You remember the first thing we do under simplify?
Adding like terms.
Okay, there is adding like terms under simplify, but that's the second thing. But that is going to be the next thing I wrote down. Yeah. Yes. So the first thing we do is, let me just fix the order on those. First thing we do is distribute. So that should say distribute. And then the next thing is combine like terms. Right, so those are the first 2. What's the next letter? Well, you know it's Sam, so the next letter is A. What's the A stand for? Yeah. Yeah, go ahead. So it stands for, what did you say? Addition, yes. So the A stands for addition and subtraction. So remember, we always have to do the opposite operation. We're trying to get the variable alone. So if we see addition in a problem, we're going to cancel it with subtraction. If you see subtraction, you're going to cancel it with addition. So we've got simplify. We've got addition and subtraction. What's the last letter? We have S, A, and then, yes, Michael?
Multiply.
Yep, M is multiply or divide. Okay, and again, I'm not going through all the steps again with addition and subtraction because we just reviewed it in the warm-up, and you guys that were all here on Thursday, we already went through it all, a lot of detail. So that's the big thing. S, A, M. That's how you remember the order to do it. Any questions on those 3 steps? Simplify, add or subtract, and then multiply or divide. Okay, so there's not really a lot of new steps, same steps we had before. We're just going to look at some problems that have variables on both sides. So let's start with this one. Now, if we want to get y by itself, the first problem we have to deal with is at least getting all the y's on the same side. Now, we can choose. Do we want to put all the y's on the right, or do we want to move them all to the left? Depending which way we do it, we might end up with a positive or a negative number. If we could choose, what type of number do you think we would rather work with? A positive number or a negative number? 80? Positive. All right, so if I could choose, I would rather get a positive value. So does anybody see how we could do that? Do you think we want to move all the y's to the left? Or do you think we want to move them all to the right? We can do it either way, but we want to end up with a positive. Yeah, Sean? Let's try putting the y's on the left, all right, and see what happens. So we want to take this, and we want to move it to the left. What kind of 5y is this? Is this a positive 5y or a negative 5y? Yep, Lexi? That's a positive 5y. So how about, Mia, can you tell me, how would I cancel out positive 5y? Yep, we're going to subtract 5y. So minus 5y, minus 5y. And when I do that, Cadence, what's 5y minus 5y? 0. That's the whole reason why I did it. I wanted to cancel that out, and I did. Notice when I minus the 5y, I line it up as like terms. I want all the y's in one column on the right, and I also want the y's in their own column on the left. Now I can do 7y minus 5y. What is 7y minus 5y? Sean? 2y. So I've got 2y. What else is still on the left side? I need to still copy this down. Yeah. So that's going to be on the right. So we do need to copy that. But what else is still on the left? Yeah, Teresa? 13. Positive or negative 13? Positive 13. All right. So I should have mentioned it, but I didn't here. We didn't have any simplifying to do. There was no like terms to combine. And there was no distributive property. So as far as the S step, that was already done automatically. Didn't have to do it. All right. So we're in the middle of A step. We just did some subtraction. Does anybody see any more addition or subtraction we still need to do? Yes? Anyone?
Subtracted 13.
Yes. We want to get y by itself. But before we can get rid of the 2, because that's going to be under the multiply or divide step, we still have more adding and subtracting. So in this case, just like Finnegan said, minus 13 from both sides. And let's see what we're left with. Sophie, what's on the left side? Say that again.
2y.
2y. And now the right side, negative 3 minus 13. Abby? So think about like if you owed me $3 and then you owed me 13. How much do you owe me now? Total. You owe me 16. And because you owe me, that's like a negative, right? Because you owe me money, negative 16. All right. I don't see any more adding or subtracting. We're done with that step. Now we're at multiply and divide. So what's my last step to get rid of that 2? Yes, Michael?
Divide 2 from both sides.
Good. We're going to divide 2 on both sides. That's gone. And Michael, can you tell me what I get?
Get negative 8.
Negative 16 divided by positive 2. Negative divided by positive. Excuse me. That's a negative. And 16 divided by 2 is 8. So negative 8. Any question on that? And this one, it just said solve. It didn't say check. So all we had to do was solve it, and we're done. Any questions on that? All right. I'm going to give you guys a second to try this one. Okay, so remember your steps. Now, I know on your guided notes, the next thing you see is it's possible that some equations have, and there's some blanks to fill in. We'll fill those blanks in after. So just do example 2 at the bottom, and then we'll come back to filling in those blanks. So take a couple minutes, see if you can do it, and we'll walk around. If you get stuck, just let us know. All right, so first step, okay, under simplify, do we have any distributive property in this one? How would you know if you had distributive property? What would you see? Yeah? You would see parentheses. There are no parentheses there, so no distributive. Next thing under simplify is combine like terms. Combining like terms is something you do on the same side. It's not the opposite operation where you're moving something from one side to the other. So does anyone see either on the left or on the right, are there any like terms we need to combine? Yep. Right. So for now, block that other side off. Forget about it. We're not using that other side at all. We're just going to take this and combine it with that. And Caleb, if I combine those together, what do I get?
You get positive 11H.
So if this was a plus 3, then I would say yes. 8 plus 3 would give you 11.
Distributive, so you're not just...
No parentheses, so we're not distributing.
So it'd be 5H.
Yes, so 8H and negative 3H is 5H. Now copy everything else down that didn't change. We didn't do anything with the plus 5. And we didn't do anything with the right-hand side. Now this problem is just like the last one. Okay, but we had an extra step first. All right. Anyone think they could tell me what to do next? We're at the adding and subtracting step. Tirza?
Subtract 5 from negative 4.
Subtract, so you did minus 5 on both sides? Okay, so you could minus 5 on both sides. That's not wrong. The only thing is it's going to lead me to a lot of negatives. I can still get the right answer, but it might be a little more work. Does anyone see something I could do on both sides that would leave me with a positive result? Yep.
I
bring the 8H over and combine it with the 5H?
So you're saying to subtract 8 from both sides?
Yes.
8H?
Yeah.
Well, if you do 5H minus 8, think about what's 5 minus 8. Is that a positive or a negative?
No, that would be negative.
That'd be negative. So let's do it the other way. Let's subtract 5H and 5H from both sides. When we do that, Abby, what's 5H minus 5H? If I had 5 minus 4, that would leave me with H. You have 5, you spend 5. What do you have left? I give you $5, you spend $5. 0. So that's gone. 0. It cancels out completely. So now we have 0H, but you don't have to write 0H. It's gone. Let's just put 5 equals. And Natalie, what's still on the other side?
8H minus 4.
So you said, I like the minus 4, but how about 8H minus 5H?
Oh. 3H.
3H. There we go. So 5 equals 3H minus 4. Now that we decided to put all the things that have H's on the right, everything without an H has to go to the left. So I'm still in the addition and subtraction step. How about Maya? Do you see what I would do next? That still is going to be addition or subtraction?
Plus 4
Yep, we're going to plus 4. Where?
to the 5.
To the 5? Anywhere else?
No.
So we did it on the left. Where else do we have to do it?
Oh, on the other side.
Yeah, we got to do it on the other side. All right. So Finnegan, if I do that, 5 plus 4 gives me how much?
9.
9. And Sophie, what's still on the right-hand side? 3H. Good. Well, minus 4 plus 4 is 0. That's gone. So now we're down to our last step. We did the adding and subtracting. We're now at the M. Multiply or divide. Does anyone see multiplying or dividing, Lexi? Yep. And divide the 9 by 3. 3 divided by 3 is 1. So that's gone. So we get H equals, Aiden, what do I get on the left? H equals 3. Perfect. Okay, any question on that? That one had a few steps. Combine like terms. Then we had to do some addition and subtraction. And then some more addition and subtraction. And then finally some division. So that one had four steps. Any questions on that? All right. What did we get for the answer to this problem? Yeah?
A positive number?
Can you tell me what positive number?
3.
3. The answer to this problem was H equals 3. That is the only answer. 3. Not 5, not 1, 3. 3 is the only answer to this problem. When you solve equations, this is on your guided notes to fill in, there are some equations that you will solve that don't have an answer. That means no, even if you do all the steps right, you don't get an answer. So there are some equations that have no solutions. Well, for other equations, any number is a solution. That means it's an equation that no matter what you fill in, every single number you can think of works. You can't find a number that will not work. Every single number works. So there's really three different types of cases. The type of case we've been doing all along, which has a single number as an answer, just like the last problem. There are some equations you try to solve and you don't get an answer. That's the second type. And the third type is where any number is a solution. Now, if any number is a solution, that type of equation is called an identity. So most of that you guys already have printed. You just have to fill in the underlined parts. So if any number is a solution to an equation, that is called an identity. These types of problems, the no solution and the any number being a solution, generally only happen when you have variables on both sides. Before today, we never dealt with variables on both sides. That's why this never came up. Does everybody have the underlined parts filled in? All right, let's try an example. Okay, so example 3, that's on the back of your guided notes. Don't take up all the space for example 3 because there's a 4 and a 5. I just forgot to print the 4 and the 5. So you could probably do even example 3 up at the top, and then 4, and then 5. All right, so after looking at the last two problems, especially the last one, does anybody see what I need to do first here? Yeah?
Combine 2a, 5a,
Combine 2a and what?
and negative 5a.
Negative 5a. Good. So first step, think of Sam. Look for distributive property. Nope, don't see it. Then look for then look for combining like terms. We do have like terms. So Brady just told us what they were. 2a and negative 5a. All right. Micah, if I combine 2a and negative 5a, what is that going to be?
Negative 3a.
Good. Negative 3a. And Micah, what do I do with the rest of this?
You try to break down.
Just bring it down. Good. Plus 4 equals 4 minus 3a. Now we want to get all the a's on the same side. Let's say we wanted to move this one over there. This is the addition and subtraction step. Okay, we're done with simplifying. Emily, how would I move negative 3a to the other side? So our choices are adding, subtracting, multiplying, or dividing. Yes. And what would you add to move this over to here? Think about what we're trying to move. What are we trying to move? The what? Yep, we're trying to move that negative 3a. So we want to cancel it out. That's how we move it. What cancels out negative 3a? Exactly. Positive 3a. And if we do it on the left, Caleb, where else do we have to do it?
You're going to have to do it to the right.
Good. We're going to do it to the right. Now watch what happens here. Finnegan, what's negative 3a plus 3a? 0. So all I have on the left is 4. How about Abby? What's negative 3a plus 3a? 0. Well, that's never happened. All variables just disappeared from the problem. When all the variables disappear, we're done. We have one of two special things that just happened. We either have no solution to this, or any number is a solution. Look at what we've got. 4 equals 4. Is that true? Does 4 equal 4? Yes. Because this is true, any number is a solution. Whenever all the variables disappear, now you're down to one of two answers. No solution, or any number is a solution. Any number always happens when you end up with the same thing on both sides. Okay? So we had same number on both sides. That's why any number is a solution. 4 equals 4, 7 equals 7, 8 equals 8. If you end up with the same number on both sides, that's your answer. Any number is a solution. Okay, any question on that? So let's try one more type where we have variables on both sides, and then we'll finish with our word problem. All right, so this one says, and again, just do it right below example 3. I would say right in the middle of the page, maybe, and then leave room at the bottom for example 5. It says 5 plus 2x plus x equals 5 minus 2x plus 5. All right. Anybody think they know what we need to do first? Yeah, Lee. Good. We're going to combine 2x, positive 2x, and positive x. And can you tell me what will be on the left when I do that? Yep. Anything else? Yes. So we still have the 5. We didn't do anything with that. And we combine 2x and x to get 3x. How about on the right? Anyone see what I need to do there? Yeah, did you go?
Subtract the 5x minus 2x.
Yeah, I've got a positive 5x and a negative 2x. So I have to combine like terms not only on the left, but I also have to do it on the right in this problem. And Sean, can you tell me when I do 5x minus 2x, I would get 3x. You know what I want to do? I want this to be a little different than the last one, so I'm just going to change one number. Just make that a 15. So in the original problem, just put a 1 in front of the 5. Okay, I didn't have to do that, but I want something different to happen in this problem than the last one. So change this 5 to a 15. Okay, so we did the simplify. Natalie, what's the next letter after the S? A, which stands for? Addition and subtraction. Does anybody see what I could do on both sides to put all the x's on one side? Yeah? So we want to put all the x's on one side. Yep. subtract 3x from both sides. And how about Anaya, what's 3x minus 3x? 0. And 3x minus 3x again? Still 0. So all our letters just disappeared. How about Abby, what's on the left side now? 5. And on the right? 15. 5 equals 15. Is that right? Does the number 5 equal the number 15? No. So what do you think the answer is here? Yeah? This is no solution. What that means is I gave you an equation that does not have an answer. It's impossible to get an answer in this problem. So no solution because, how did I write it before? We had the same number on both sides. This time we had a different number on both sides. So when you end up with a different number on both sides, 5 equals 15, 2 equals 6, 3 equals 12. That's not true, which means there is no solution. Okay. Any question on that? All right. Let's look at the last one. I usually print the word problem. I think I forgot to print the word problem on this one. So I'm just going to give you the word problem kind of step by step. So this one says, size pizza shop charges $10 for a cheese pizza and $1.50 for each topping. So that's the first pizza place. So what I'll do is I'm going to highlight that in yellow. So size pizza shop charges $10 for a cheese pizza and $1.50 per topping. Yes. Yeah, you'll have to write this one down. Usually, I print it, but I forgot to print it. I think it's only 3 sentences. So that's the first one. So the second one says, Bay's House Pizza. Let's see, what do they charge? They charge $12.50 for a cheese pizza. But they charge $1 for each additional topping. So that's the other pizza place. So they charge more money for the pizza, but they charge less money per topping. So depending on how many toppings you want to get, one pizza place might be better than the other. Depends. If you don't want any toppings, well, then I would just go with the place that sells the pizza cheaper, because you're not going to get any toppings. So what we want to do is write and solve an equation where you would pay the same amount of money no matter where you ordered the pizza from. So I want to write and solve an equation that will help me figure out where I could order the pizza from, and it wouldn't matter. It would cost the same if I get it from Size Pizza Shop or Bay's Pizza Shop. So let's start with what's in yellow. Size Pizza Shop. How much money do we pay for a pizza if we get it from Size Pizza Shop? Yep, $10. Now, is that all we pay for? What else do we have to pay for if we choose to get these? Yep, we got to pay for toppings. So for Size Pizza Shop, we pay $10 plus, how much do we pay per topping? Yeah? $1.50, and is that, we just pay $1.50 for all the toppings? Or do we have to pay $1.50 for each topping? Each. So it's $1.50 times how many toppings we get. If we get one topping, we pay $1.50 plus 10. If we get two toppings, that's going to be $3. So that's the cost from Size Pizza Place. Does anyone think they can give me the cost from Bays based on what we did on the left? You have to put the price plus how much you pay per topping. Yep.
$1.
What's it start with?
Oh, starting with $1. That's okay.
So what's the price of the pizza from Bays?
$12.50.
$12.50 plus how much is each topping? $1 times how many toppings we get. So times 1x. So this is the cost from Size. This is the cost from Bays. And they said to write an equation where they come out the same. So set the cost of one pizza place equal to the other and solve it. And this will tell you how many toppings you could get, and it would not matter which pizza place you ordered from. All right, so let's start by, how would I move this 1x to the other side? Finnegan?
Minus 1x.
Minus 1x. Minus 1x. What's 1.5 minus 1? Yep. Good. 0.5x. All right, so we put all the x's on the left. How would I move this 10 to the right? Oh, John?
I subtracting 10.
Good. Subtract 10 on both sides. 10 is gone. 0.5x equals, what's 1250 minus 10? Yeah? 2.5. 2.5. It's like $2.50. And lastly, we have 0.5x. How do you get rid of the 0.5 in front of the x? Yep.
You divide.
Yep. And what would you divide by?
0.5.
Nice job. Okay, we can use our calculator if we're not sure on that. 2.5 divided by 0.5 is 5. So what that means is if you ordered 5 toppings on your pizza, it does not matter which pizza place you ordered from. It's going to be the same price. And that's it. All right, so remember, homework tonight. It's the 1.1 to 1.3 reference sheet on Schoology. Remember, that's a review of all the problems we've done so far.